In this video we're going to go over the distributive property. We'll look at these 3 pages. Here's page 1, page 2, okay, and page 3, right? So the distributive property is this. Okay, write down the answer to 3 times 7. What's 3 times 7? 3 sevens is? 7 and 7 is 14. 14 plus 7 is? It's 21, right? Now, one way we can look at that, just for fun, just so we can learn the distributive property, is 7 is the same thing as 5 plus 2, isn't it? So I can write 3 times 7 in a new way. So write this down. 3 times 7, and then underneath that write 3 parenthesis 5 plus 2. So write this down. Okay. So this is another way of writing 3 times 7, because 7 is 5 plus 2, right? And I could take, 7 squares, 1, 2, 3, 4, 5, 6, 7, and I could split the 7 squares into 5 squares and 2 squares. So you've got 5 green ones and 2 red ones, I guess. Okay. Now this is 7 split into 5 plus 2. Now I want 3 of these. So that means 3 sevens, or 3 of the 5s plus 2s. Do you see what I mean? Because these are each 5, 5, 5, 5, and then we've got, on the reds, we've got 2, 2, 2. So this is 3 sevens. You see there's 3 of them, 1, 2, 3. Each of them is 7 long. That's 3 sevens, but it's also the same thing as 3 times, 5 plus 2. And one way of, what I'm going to show you is that, like, what's 3 times 5? 3 times 5 is 15. See, we've got 15 green squares, and we've got how many? What's 3 times 2? How many red squares do we have? 6, right? And what's 15 plus 6? It is 15 plus 6 is 21. So basically that's the distributive property shown in the diagram. And I mean, the distributive property is, if you have a number times things being added inside of parentheses, you can take this number and multiply it by each thing. So like 3 times 5 is 15, you see? And 3 times 2 is 6. So I can calculate this as 3 times 5 is 15, 3 times 2 is 6, and then 15 plus 6 is 21. Why do we need to do this? Only because on page 3 and in algebra we have to deal with letters, and so we actually do have to use the distributive property when we have letters. It's not necessary for numbers, obviously. We could have just done 3 times 7 is 21, but this is just showing you why it works. So like 3 times 6 plus 1 is another way of writing 3 times 7. What's 6 plus 1? It's 7, and 3 times 7 is 21. But if I use the distributive property, please write this down and then go 3 times 6 is 18, right? And what's 3 multiplied by 1? 3 multiplied by 1 is 3. And what's 18 plus 3? It is 21. And there's another diagram to show that. Like, each of these is 7 long. 1, 2, 3, 4, 5, 6, 7. And it's split into 6 plus 1. 6 plus 1. 6 plus 1. So we have, this is 6, 6, 6. And then we have 1, 1, 1. So we've got 3 6's, which is 18. And 3 1's, which is 3. And if I add them together, of course, I get 21 squares, or 3 times 7, right? So in any case, that's just for fun. Another way to, another kind of use for the distributive property is when we do long multiplication. 25 times 3 is, in fact, 20 plus 5 times 3. So we're going to do long multiplication soon, and it uses the distributive property. Because what we do is, we don't try to multiply the whole thing all together. We go 3 times 5 is 15. See that? And 3 times 20 is, what's 3 times 20? 60, right? And what's 60 plus 15? 75. So long multiplication is doing this. 3 times 5 is 15. Put down the 5 and carry the 1. 3 times 2 is 6 plus 1 is 7. So it kind of uses the distributive property because you're multiplying 3 times 5 to get 15, and then 3 times 20 to get 60, and then you add 60 and 15 to get 75. That's actually what we did over here. So it's kind of useful to know about it. Okay, another way, so the distributive property with letters, I'm going to go over that now. If you have, imagine this is a sack or a bag. In the bag we've got an apple and a banana. Really bad drawings of an apple and a banana, mind you. But in math, here's a way to represent that. Here's the bag. It's a parenthesis. Apple could be represented by the letter A. Banana could be represented by the letter B. We have an apple and a banana. You could represent and with plus. So there's 2 bits of fruit in there, an apple and a banana. Let's say it's Halloween and you've got a whole bunch of these bags ready to be handing out to the kids when they trick or treat. So let's say we put the number 10 in front of the bag. What would that be communicating? If you put the number 10 beside a bag, what is that saying? It's saying there are how many bags? It would be saying there are 10 bags. Does that make sense? If you put the number 10 beside the bag, it's kind of saying there's 10 bags. So if I put the number 10 here, it's kind of like saying there's 10 of all of this. There's 10 bags. So there's not just 10 apples, but there's also 10 bananas, right? There's 10 of everything. Because there's 10 bags. And so you can use the distributive property on this and go 10 times A and then 10 times B. Now 10 times A is 10 apples. So you can just write this, 10A. See that? 10 times B is, how would you write 10 times B? 10 bananas. 10 apples, 10 bananas. And we have this and this. So to represent and, we put plus. So 10A plus 10B, that's 10 apples and 10 bananas. Now, of course, these are not like terms. You can't add them together to say that makes 20 apples or 20 bananas or 20 bits of anything. I mean, so you just kind of leave it as 10A plus 10B, and that's the answer. Okay. So just for fun, here's a bag with 2 apples and 3 bananas in it. Okay. What happens if I put the number 4 outside here? What is that communicating, and how many apples and bananas do I have? Tell me. Oh, I can hear you. Just joking. If I put the number 4 here, how many apples do I have? Because the 4 here means you got 4 bags, right? 4 bags. So how many apples do you have? 8 apples, right? And how many bananas? Because I got 4 whole bags, so how many bananas? 12 bananas, right? So that with algebra, this looks like this. 2 apples is 2A. 3 bananas is 3B. I have 2 apples and 3 bananas in a bag. Okay, parenthesis. So this is how you'd write that with algebra. Number 4 to show outside to show I've got 4 bags, you'd put 4 here. And you can use the distributive property to get the answer. So you go 4 times everything basically. 4 times 2 apples is 8 apples, 8A. 4 times 3 bananas is 12 bananas, right? 12B. So I've got 8 apples and 12 bananas. And that's the answer. So I'm just giving you a quick introduction to algebra with the distributive property, just for fun. So we'll go to page 3, and you know, something like this, you know, 4 times x plus y is very similar to 10 times a plus b. You could imagine this as x, I don't know, something like piece of candy, and y could be a yo-yo. So you've got a piece of candy and a yo-yo in a Halloween bag. You've got 4 of these bags, so how much of everything do you have, right? So you'd have 4 pieces of candy and 4 yo-yos, right? Because you've got 4 of these bags. So the distributive property is you take the number outside the parentheses and multiply it by everything inside here. So 4 times x, 4x, 4 times y, 4y. 4 pieces of candy and 4 yo-yos. 4x plus 4y, right? How about this one? 7 times x plus 4. What would you do with that? 7 times x plus 4. You've got a bag. In the bag there's a piece of candy and $4, let's say. 7 is beside the parenthesis. There's 7 bags. So that means there's 7 of everything in here, right? So 7 of these and 7 of these. What would you... 7 x's. How would you write 7 times x? 7 x's would be written... Take a guess. 7x. That's all. 7x. What about 7 times 4? How could you write 7 times 4? 28. Right? Done. So that's the answer. 7x plus 28. Now, this is 7 pieces of candy plus $28. These are not like terms. So they don't make, 35 pieces of candy or $35, do they? You can't add candy and dollars. That doesn't make any sense. So they're not like terms, so you leave it alone, right? So how about 3 times n plus 8? Write down the answer to this. Three times n plus 8. You've got the number 3 on the outside, touching a parenthesis. So 3 bags. Inside the bag you've got a you've got an n and an 8. N could be what? Oh, I can't think of it. $8, right? So it would be 3 of these bags, so 3 of these and 3 of these. How would you write 3 n's? 3 times n? 3 n's, right? 3 times n. How about 3 times 8? What's that? 24, right? So the answer would be just 3 n's plus 24. And n's is not the same as just, like, this is not 27 n's or just the number 27. Because this is n's and this is units. So they're not the same term. You can't add them together. If you had 3 n's plus 24 n's, that would be 27 n's. If you had 3 apples plus 4 apples, that would indeed be 7 apples. If you had 2 bananas plus 5 bananas, that would indeed be 7 bananas. But if you have 2 apples and 3 bananas, what does that make? That's just 2 apples and 3 bananas. There's nothing you can do, okay? So, by the way, I'm just talking, that's a nectarine. This is $8. A nectarine and $8 in a bag. 3 of these bags gives you 3 nectarines plus $24. And you cannot add nectarines to dollars, so you're done. That's the answer. Similarly, like if you had 2 apples plus $5, what would that make? What's 2 apples plus $5? Is it 7 anything? That's just 2 apples and $5. There's no way of adding things that are not the same, right? Anyway, that's all.